Greetings and welcome, friends. Mr. Waddy here. Today we are talking about section 5.6 in Algebra 1, graphing linear inequalities in two variables. Now, we've graphed linear inequalities on a number line. We've done if x is greater than 3, or sorry, that's less than 3, right? We've graphed like the open circle at 3 and shaded this way, right? We've done that. It's going to be similar ideas to that, except now we're working on in a coordinate plane and not a number line, a single dimension. So here we go. It says a linear inequality in two variables, x and y, can be written as the following: blah, 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 blah. Right? They can have less than or equal, greater than, and greater than or equal to signs. And a solution of a linear inequality in two variables is an ordered pair x, y, so two numbers, right, ordered pair, that makes the inequality true. So here, let's just jump into that. Let's see, is this a solution? Is this x, y a solution of this inequality? And so what I'm going to do is plug it in, do a check. So 2 times -1, is that plus 9, right? So I'm plugging in for both of those. This 9, I don't need the parentheses on. Is that less than -3? So 2 times -1, -2, plus 9, is that less than -3? I get 7 less than -3, which is not true. So that means that this is not a solution. Okay, not a solution. Now, there are going to be x-y combinations that will be solutions of this, but right now we're just checking whether or not this is a solution. So let's do it for this one over here. So here's an x-y combination. I'm going to plug them in for x and y and see if it works. So is 2 minus 3 times -2, is that greater than or equal to 8? 2. -3 times -2 is positive 6. And is 8 greater than or equal to itself? Yeah. Yes. Now, if it didn't have the equal part, it would have failed. Right. I'm plugging in 2 for x and -2 for y. Yeah, here this little semicolon thing that was separating the equation, right? So I'm just plugging it in and checking, right, whether or not these are solutions. So yes, this is a solution. Hooray! This is a solution. All right? So that's how we can do checks. So a solution of a linear inequality in two variables is going to have, truth when you plug in the x, y is the idea. All right, here we go. These, I like these. I feel like the shading here could have been a little bit brighter of an orange, but either way, it reminds me of like Mass Effect with like the cool like Omni tools. But it's all right. Yeah, it's enough. It says the graph of a linear inequality in two variables shows all of these solutions, of which there are infinitely many, in a coordinate plane. So all the solutions of y is less than 2x look like this. So here's the line y equals 2x. And if my solutions are y less than it, I have a dashed or dotted line, I say sometimes, even though it's dashes, we all know that. A dashed line. And the points less than it are everything underneath it. Everything less than that line. And since this is y is less than, I'm thinking vertically speaking. So everything less than this line is a solution, okay? And so this divides the coordinate plane into two half planes, right? So half of the numbers on the coordinate plane are solutions and the other half are not. And the shaded half plane is the graph of y less than 2x. So that's what these are going to look like when we graph them, all right? And there's going to be dashed lines or solid lines, just like we used to have open circle or shaded closed circle, right? Same idea. So here's the process. So if I'm graphing a linear inequality in two variables, first I graph the boundary line. All right, so I'm graphing like a regular line, y equals mx plus b, possibly. And then use a dashed line when it doesn't include the equal part, and use a solid line when it includes the equal part of your inequality. Step 2, what are you doing? Test a point that is not on the boundary line to determine what... No, this is not the most effective way. I'm not a fan of step 2 at all. Yikes. I'll show you guys how to do it. We'll use logic to figure it out. Now, that's a way you could do a check, but yeah, it would work. It's just I think it's more work than necessary. To determine whether it's a solution of the inequality. When the test point is a solution, then shade the half plane that contains the point. And when it is not a solution, shade the half plane that does not contain the point. That is the weirdest... Wow. I'd rather be able to deduce more about it using kind of the logic. You'll see what we do. It'll make sense. I mean, you're welcome to use their method. I won't mark you wrong, but I'd rather teach you guys a more effective way. So here we go, example 2. All right, graph y is less than or equal to 2 in a coordinate plane. So y is less than or equal to 2. Let's think about this in terms of slope-intercept form. All right, this is going to be a horizontal line, even if I don't write it in slope-intercept form like this, with a y-intercept at 2. So let's plot that y-intercept of 2, and then draw the horizontal line, all the points, right? Now, question, is this boundary line going to be a solid line or a dashed line? What do you guys think? Does it include the equal part in the inequality? Yeah, it's got the equal part over here, so it's going to be a solid boundary line, right? Solid boundary line. And the values that are less than this, because this is a y relationship, y is the vertical axis, less than would be below, greater than would be above. So less than means below when I'm talking about y's. So less than would be below. All right, the equal part means solid, right? A solid line. And so if I want to shade the things that are below, now I can do some like all sorts of, you know, shading. Everything under here is a solution. So you can just kind of like color that in a little bit, and we'll see what you're talking about. Eventually, you won't want to shade it too much because there will be situations where we have tomorrow more than one graph, and I don't want to just like color all over some stuff. Actually, tomorrow I'll even have you guys work with some colored pencils, I think. But yeah, so that's the idea. You graph the boundary line, and then you shade one side or the t'other. All right, here we go. Here's another one. Ooh, I like it. I like it. Here we go. So this one, we do know how to graph using the intercepts method, where I plug in 0 for x to find the y-intercept, plug in 0 for y to find the x-intercept. But let's just switch this over to slope-intercept form, because we know how to do that, and I think that's a great way to do this. So I'll get y by itself by adding x to both sides. Oh, there we go. So I'll have 2y is greater than x plus 2, and then I'll divide everybody by 2. And let's see, so I'll have y is greater than 1/2 x is the way I want to write that. So that way it's more obvious that the slope is the 1/2 by writing it in front of the x. Plus, and then 2 divided by 2 is 1. So here's my inequality. Now this is y by itself. So y greater than. Now looking at this sign, I'm expecting that it's going to be shaded above. Right? And do you think it's going to be a solid or a dashed line? Well, it's missing the underline, so it's just going to have a dash. Just a dash of y coordinates. It's going to be delicious. And let's graph this. I'll use using slope-intercept form. There we go. The slope is 1/2, and what's the y-intercept? Is the 1, right? Yeah. So let's graph this. I guess I'll use purple again. So y-intercept is 1, so I'll plot that point, and then I move by my slope up 1 over 2. up 1 over 2, up 1 over 2. And you guys, you could use a ruler or something if you want. You would then draw a dashed line, not a solid line, a dashed line here. Let's see how big my dashes are going to be. I've got let's see. Is this, no, I don't want bricks. I want I think I want these. Yeah, dashes, perfect. Can I change the size of it? Oh, actually, I would want, we'll try it. Let's see if this works. Ah, that's terribly just not what I was looking for. Here we go. Let's see. Let's change this. Can I make mine all cool and dashed? Yep. No. I would need I shouldn't use my ruler tool. I should have used my line tool. But anyways, I've got a dashed line, right? You see what's going on here. And now which points are my solutions? The one above or the ones below? Above, because greater than, okay? And so now I just go and shade everything above that, like so. All right, so my solutions, let's actually talk about some of the solutions here. Is 0, 0 a solution of this? Is the origin a solution of this right here? No, it's not in the shaded region. How about this point? Is 2, 2 a solution? No, it's on a dashed line, so that means the solutions were everything up to it but not including it. How about 2, 3? Yeah, 2, 3 would have been a solution, right? There's infinitely many of them here. Negative 2, 1 is a solution, right? I just want to point out, like, all of those are solutions. Any points on the line won't count for us. Those are not solutions in this case, okay? But that's the idea, is make a graph is what I do. Let's see, let me actually make, I want to do monitoring progress question 6, because these are a little bit interesting for vertical lines, and I guess no, you don't? All right, well, we'll definitely do 7 and 8. You guys can just watch for this one. So this is the equation of a vertical line, all right, because it's x related to a number. The graph will be x less than or equal to -4. So at -4 on the x-axis, I would plot a point, and it would be a vertical line right here. Now, do you guys think this would be a solid line or a dashed line? So it's solid because of the equal part, and less than, that's where this is going to get interesting. Let me draw the graph, and we'll figure out what less than means. Well, the problem is there is no bottom part for a vertical line, right? So it's a solid line. What does less than mean for a vertical line? Well, in terms of the x-axis, over here is the positive side, and over here is the negative side. So I could only refer to less than in terms of left or right. Which way do you think is less than this line? To the left, yeah. So I'm going to shade to the left, and it's only for vertical lines you think of left or right. All of the other lines, diagonal or horizontal, you're going to think of in terms of above or below. So I shade to the left because that was towards the negative x-axis, right? And that was less than, right? Left, less, right? So I just said right at the end of that. That was not as helpful. So let's see. Let's take a look at one of the other lines, because I think, yeah, 7 and 8 are more interesting for the monitoring progress. And then let's see. Yeah. Yeah, we'll do these two real quick. 7 y 8. All right, and I'll get a couple graphs for myself here. Couple little graphs with the grids. I think I gave myself enough space. We'll see. I'll move these down here. So So here's two separate problems. Let's put this in slope-intercept form first. How could I put this in slope-intercept form? I got to solve for the y. So we would subtract x from both sides. And I'd have y. Do I have to flip the inequality for that? No. We only flip inequalities when I multiply or divide by a negative. All right, so looking at this, less than or equal to, this is a y line, right? So I'm going to think about it in terms of above or below. Which way am I shading, above or below? For a less than sign, so below. And the equal part means it'll be what, solid or dashed? Solid. And then we might as well, while we're here, talk about slope. What's the slope? Yeah, there's a little invisible 1 there. So -1, and the y-intercept, -4. So here's -4 on the graph, and let's move down 1 and over 1, and down 1 and over 1. And I can also get the same thing by going up 1 and backwards 1. And let's draw this line. So I'm expecting a solid line because the equal part of the graph, something like that. Solid line. And now I'm shading above or below? What? Below because of less. And for any line that is not a vertical line, you only think of above or below. Don't think about left and right with respect to this. I'm thinking up and down because this is solved for y. And y is a vertical, right? The vertical axis, so this is a vertical relationship that I'm talking about. All of the points that are less than this line. And so that's what that graph would look like. Let's do this other one super quick. Subtract x from both sides. Right, we're so good at solving these days. -2y is less than -x plus 0, or just -x, I guess. And what do I do to both sides now? Divide by -2. And I just said the magic word, divide and negative. So I flip the inequality. And let's see, negative divided by negative is +1/2 x. Okay, so I had to flip that inequality. So when you multiply or divide by a negative, make sure you are careful, friends. Let's see, this has a y-intercept at 0. We'll just start graphing it and see what happens. Slope is 1/2, so up 1/2. Up 1/2. And you're arguing for a dotted line? Why? Because it doesn't have the equal to part. I think so. You're arguing to shade above. Let's see, I'll get my little dashes going here. There, that's a good enough dash. Just a dash of salt. All right, and I'm going to shade above. I could even use this crazy shading. Let's see, is this going to... That beautiful shading. Wow, I love it. Right, shaded above the line because it was a greater than sign. All right, so these aren't too crazy, I don't think. These aren't too crazy. Let's do just example 4. We'll call it a day. A day in the world of math, the most wonderful day. Let's see, where's my scroll bar here? Okay, word problem. What? Okay, here we go. So, you guys know the routine. I'm trying to write letters with this. I just tried to write the letter V. That does not work. Okay, let's see. Let me get my pencil out. There we go. V equals. All right. Or V colon. I gotta define my variables. It says you can spend at most $10 on grapes and apples for fruit salad. Ooh. Grapes cost $2.50 per pound. Apples cost $1 per pound. Write and graph an inequality that represents what? The amounts of grapes and apples you can buy. That sounds like my variables. Identify and interpret two solutions. Let's see. How do I measure amount of grapes? Oh, these are measured in price per pound. So I'm probably going to want X's pounds of grapes. Oh, yeah, or LB. I like that. LB, LBS, ELBs, pounds of grapes. And let's let Y equal ELBs of apples. And now let's write, I was going to write E for equation, but in this case, this is going to be an I for inequality. And there's going to be just one inequality here. Okay, so this is where it's a little tricky. It says you have at most $10 to spend. So that's the biggest number that I got, and that means my variables, the amount I spend on that, whatever is over here has to be less than or equal to 10. Because fruit stand Stan is not going to give you more than $10 of fruit for your $10 bill. Yeah, iced tea at a lemonade stand. What? See, it says grapes cost $2.50 per pound. All right, and apples cost $1 per pound. So let's see. I'm going to spend $2.50 or 2.5 multiplied by the number of pounds of grapes. So $2.50 per pound multiplied by the number of pounds. What I get is a dollar amount that I spend on grapes. Okay? Plus, then I spend $1 per pound on apples. So that's $1 times the number of pounds of apples. Right? And this 1y term would represent the money I spend on just apples. And if I add money to money, I get money. Actually, maybe. More money, maybe, yeah. So that's my inequality. So let's solve this. And there's going to be multiple solutions. Let's put this in slope-intercept form. Why not? Let's subtract 2.5x from both sides. So I'll have y. Do I have to flip the inequality? Right, and well, actually adding and subtracting, I can do whatever, right? I don't have to flip it. So let's see, y is less than or equal to negative 2.5x plus 10. So here is my inequality. Let's see if we can graph this. So my x-axis is grapes. My y-axis is apples. The slope is negative 2.5. Let's see. Will I have enough space? No, I've got to go up at least to 10. Yeah, I'll just count by ones, I guess. And negative 2.5, by the way, is the same as negative 5 divided by 2. You guys know that? Right? And so I'm going to use that as my slope since I'll just count these as ones and my origin is going to be right here. You're aware. So let's graph this. I guess I'll use purple, which is kind of like the combination. Oh, I guess that's a grape color. Apples could be red. Grapes can be green. Red and green combined to be, I don't know my colors. So let's see. Let's start at 10. So up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, there's one of those points. And my slope is down 5 over 2. All right, that's the easier way to graph it. 1, 2, 3, 4, 5 down and over 2. And I'll move that again, down 5 and over 2. Now the question is this going to be a solid line or a dotted line? So it's solid because of the equal part. And am I shading above or below? Below because of less than. All right, so let's draw this line. I think we did a graph kind of like this yesterday. And this time, we'll have even more possible solutions. Now, I don't know. Do you guys live in a world where there's a thing such as, like, anti-grapes or anti-apples? Is it possible to buy, like, apples made of antimatter? I don't think so. Like, what's, like, negative 10 pounds of apples look like? Could be money if I'm selling them back to this guy. So my solutions actually won't include any negative values for that. That's one of the reasons why I'm working in this, just the first quadrant here. But my solutions are everything in this triangle. I can't have a negative pound of apples or grapes, right? That's just weird. So here's my possible solutions. Yeah. So let's pick a couple possible solutions. Would this solution work? It's on a solid line. That's the number 3, 3. All right, so that's like 3 pounds of grapes and 3 pounds of apples would work. All right, that works. That's a possible solution. But I also, the points on the line would be any combination in which I spend. Actually, that's not exactly 3, 3. It shouldn't have crossed there. It crosses a little bit less. Yeah, I don't know. Well, anyways, yeah, that's one of the problems with graphing. But let's see. Let's keep going anyway. If I don't want to spend my full $10, all right, I would pick a point less than the line. If I pick a point on the line, that's spending exactly my $10. All right. So let's see. Let's look at like this solution. What's this one right here? So that's over 1 and up 5. Yeah. So what would that represent? Well, my grapes axis is the x-axis. Yeah, and 5 pounds of apples. All right, so those are a few possible solutions, but really any number that's in the shaded region, any combination would work. Right, I also could have a fruit salad made up of all apples or all grapes if I picked something on one of these boundaries. I also, if I pick the origin, that means I didn't feel like fruit salad made up of apples or grapes. And I bought 0 pounds of both. Okay? Yeah, 3, 3. Man, that's tricky. That one didn't work. That's technically, if I picked 3, it would land a little bit less than that, I think. Because, yeah, 3 for x, 7.5. I think it would have been 3, 2.5. All right, which it is possible to buy 2.5 pounds. Yeah, 2.5 pounds of apples, I'm assuming. Right, scales work and not just whole numbers. So anyways, there we go. So thanks for watching, internet friends. Yeah, Waddy out.